Yeah, good day, guys. Today we have fantastic problems which involve with calculus and trigonometry. And these fantastic problems, there are three in number. So this is the first problem. But before that, just after you have gone through the video, make sure you like, you subscribe, and you give your comments. So moving forward, the first question says we are required to show that cosec phi divided by cot phi plus tan phi is going to give us cos phi. That this value, cosec phi divided by cot phi plus tan phi, is going to give us cos phi. That's the first part. And the second part of the question one follows. It reads, it is given that, like, simply the integral where the limits are given from 0 to a, cosec 2 phi divided by cos 2 phi plus tan 2 phi equals to root 3 divided by 4. You see, where 0 is less than a and a is less than pi over 4, using your answer from this part, that part A, your answers from part A to find the value of A given your answer in terms of pi. This is a very simple and straightforward question which we are required to solve. So like I said, we have three problems which we are going to target here. This is going to be the first problem, and from that we'll try again the second problem, and we'll try the last problem. Like I was saying, just after going through the video, before the video, try to like, you give your comments, and as well as you subscribe. Thank you. So we start from the first problem. We are required to show that this value, the left-hand side value term, must give us the right-hand side. It depends which term you want to choose. Let's say if we choose the left-hand side, we say consider left-hand side. If we consider left-hand side, consider left-hand side. If we consider the left-hand side, which is given as cosec phi divided by cot phi plus tan phi. So we are required to play with this trigonometric identity. The result we are going to have must be cos phi. But in solving this, we have to know the identities. Like the previous video, if you check on my videos, like trigonometry, wherein I took my time to derive all the related identities. So if you capture those identities, you can use them to derive this value. When you play with this value, this left-hand side, at the end of the day, the result is going to give us the right-hand side. But in this case, you have to know the identity for cosec phi. You also have to know the identity for cot phi, and as well as the identity for tan phi. You see, so we are going to solve them step by step. We consider the numerator. The identity for cosec phi is going to be 1 all over sin phi. The identity for cot phi is going to be cos phi divided by sin phi, and as well as the identity for tan phi is going to be sin phi divided by cos phi. So since you have known these three identities, cosec, cot, and tan, we slot them or we substitute them. From there, we play with our algebra. So at the end of the day, we are going to have something which will be exactly cos phi. So if we move forward, we'll take cos phi. As I was saying, the identity for cos phi is 1 all over sin phi. This is the top. We'll consider the numerator at the top. We say multiplied by, you see, or we say divided by. It's very simple. We have this division sign, divided by, we consider again this value, this identity. This identity now, we have it to be cot phi plus tan phi. But cot phi will be cos phi divided by sin phi. You know, we have a plus sign here. Plus tan phi. Tan phi is going to be sin phi divided by cos phi. So let's put this in brackets. That's the numerator value divided by the denominator. Because this division sign gave us this. So if we continue, 1 all over sin phi divided by this denominator, we consider the LCM, the least common multiple, or we can say the LCD, which can as well refer to as the least common denominator. So if we consider the least common denominator, multiply these two values, sin phi times cos phi, is going to give us sin phi and as well as cos phi. So sin phi will cancel sin phi, it means cos phi. Cos phi times cos phi is going to give us cos square phi. We write the plus sign given, And cos phi into cos phi is 1, and we have sin phi. Sin phi times sin phi is going to give us sin square phi. This is how we have this value. You see. So if we continue, 1 divided by sin phi. This division sign, we can change it to multiplication. We are in the denominator moves up. So we have sin phi cos phi divided by the numerator, which is cos square phi plus sin square phi. So if we continue, 1 all over sin phi times, we rewrite this sin phi and cos phi divided by, let's take note of, we write this value, but cos square phi plus sin square phi is 1. This will give us 1. So I hope you take note of that. So we have this value. So, but if you look at it again, we have terms that will cancel. These values, this sin phi will cancel sin phi. So the end of the day, what will remain is 1 multiplied by cos phi, which implies this left-hand side value, which is cos sec phi divided by cot phi plus tan phi will be, because 1 time cos phi, this will be just going to give us cos phi. So therefore, this left-hand side value is going to give us cos phi. So this is how we derive this value. So having noted this, we consider again the second part. The second part, the B part, we are required to, we are given here the integral of 0 to a cosec 2 phi divided by cot 2 phi plus tan 2 phi will give us this, you see, which is very simple and straightforward. So we are going to use this integral. The end of the day, we are required to find the value of a, the limit, because we are given the lower limit and the top limit. So the lower limit and this limit, the lower limit is 0, and simply the upper limit there is a. So we are required to find the upper limit, which is a, which is very simple and straightforward. So we are in, the answer here is limited. We have to take note of this condition. The condition they are given, 0 is less than a and a is less than pi upon 4. And this value, it is in radians. And in radians, it simply means 180 divided by 4. So that's going to give us like 45 degrees. So this is in degrees, while pi over 4 is radians. So our answer in terms of degree must be 0 is less than a and a is less than. That means a is going to be less than 45. So our answer will not be greater than 45. Or our answer must not be greater than pi all over 4. It should be less than pi all over 4. So this is the condition for this. So you have to take note of that. So since we are required to integrate this, which is very simple and straightforward. So let's say we clear this top and we rewrite the second part. So if we rewrite this B part given, the B part, we are given the integral of 0 to a, and we are given cosec 2 phi divided by cot 2 phi plus tan 2 phi. You see, this will give us root 3 all over 4. So we are required to use this value to find the value of a. So I think that's where find the value of a in terms of phi. So I think the question is, we don't need it again. So the same thing. So we have to simplify this. If we try to simplify this, the simplest way, let's consider this value given. Sorry, it's given as d phi. The derivative is given as d phi. So we are required to integrate this value and we equate it to root 3 upon 4. We carefully find the value of a. So in this case, the logic is going to be the same as this. So let's consider the integral given, which is cosec 2 phi divided by, we have our cot 2 phi plus tan 2 phi. So but in this case, I just want to give you the steps on how to have it. But since cosec phi divided by cot phi plus tan phi give us cos phi, therefore if here is cosec 2 phi, cos 2 phi, tan 2 phi, we're going to give us cos 2 phi. If here is going to be cosec 5 phi, cot 5 phi, tan 5 phi, it's going to give us cos 5 phi. Or let's say here is cosec 3 phi, cot 3 phi, tan 3 phi, it's going to give us cos 3 phi. This is what I'm trying to say. So since here the coefficient for this phi is 1, 1, that's why the coefficient here is 1. So since here the coefficient is 2, 2, 2, therefore the result we are going to have is the question for cos is going to be 2 phi. You see, but let's try to see how best we can use it. So we follow the same procedure. Cosec 2 phi, consider the top, is going to be 1, as we are saying, cosec is 1 upon sine. So since here is 2, it's going to be sine 2 phi divided by, we take this top, cot is going to be cos 2 phi divided by sine 2 phi plus, we take again tan. Tan is going to be sine 2 phi divided by cos 2 phi. This is what we have. So if we continue, this is going to be 1 divided by sine 2 phi divided by, the same thing, we take the LCM, sine 2 phi, and we take cos 2 phi. Sine 2 phi into sine 2 phi is cos 2 phi. Cos 2 phi times is going to be cos square 2 phi plus, this again, same thing, cos 2 phi into cos 2 phi, is going to be 1, it's going to remain as this. Sine 2 phi times sine 2 phi is going to be sine square 2 phi. This is what the steps are going to just be the same. So we write 1 upon sine 2 phi times, if we change this signature, this move up, is going to be sine 2 phi and cos 2 phi divided by, we remain cos square 2 phi plus sine square 2 phi. This is it. So if we maintain 1 all over, in this case, you can see this value, sine 2 phi will cancel sine 2 phi, right? And cos square 2 phi plus sine square 2 phi is going to be 1. So therefore, the final result is going to be 1, because this one is this, multiplication, multiplied by this. This sine 2 phi will cancel sine 2 phi, it remains cos 2 phi over cos square 2 phi plus sine square 2 phi. But let's take note of cos square 2 phi plus sine square 2 phi is going to be 1. You see, I think we derived it from the previous video. If you go in for trigonometric video, you see how we derive this. So this whole value is going to be 1. So cos 2 phi divided by 1 is just going to be 1. It's just going to be cos 2 phi. So the whole of this value is going to be cos 2 phi, which is going to be cos 2 phi, because 1 times cos 2 phi equals 2 phi. You see? So this is what we have. So this whole value has been break down to cos 2 phi. You see that? So if we integrate this now, so this integral has become the integral of 0a, and this whole value has become only cos 2 phi d phi, you see, equals to root 3 all over 4. So it has been simplified, you see. So since it has been simplified in this way, so now we integrate this value. So when you integrate trigonometric ratios, like if you integrate sine, it's going to give you cos, and if you integrate cos, it's going to give you sine. Those are the values, but you have to know which of them is going to be negative. If you integrate cos, it's going to be positive sine. And when you integrate sine, it's going to give you negative cos. You see, so if we integrate this value, so it's going to be, if we integrate cos, it's going to be your sine. See, the question here is 2, it's going to be because same thing. So this will be sine 2 phi. Don't forget, if we integrate the coefficient of the angle here, 2 phi, when it integrates 2 phi, it's going to give us 2. So the integral, you always take it 1 all over the value, because you divide it to the value given. But we are given the limit to be 0 to a, and we rewrite the limit 0 to a, and we equate this value given, which is root 3 all over 4. This is what we have. You see, I think we are almost done. So the next point, we substitute our limit, the top limit and the lower limit. We always start from the top limit. After substituting the top limit value result minus the lower limit value. So if we substitute that, it's going to be half into sine 2 into the first limit is a minus sine 2 into 0. We have this equals to root 3 all over 4. This is what we have. So if we maintain half into, this is going to give us sine 2a minus sine 2 times the 0, so sine 0 is always 0, equals to root 3 all over 4. This is what we have. So you see, so sine 2 0 minus sine 2a minus 0 is just sine 2a. So we're going to remove half sine 2a equals to root 3 all over 4. This is what we have. So if we continue the next point, 2 into here is 1 time, 2 into 4 is going to be 2. So we have sine 2a is going to give us root 3 all over 2. You see? So yeah, we take the sine, but since we take the sine inverse, so 2a is going to be sine inverse of root 3 all over 2. We have that. So 2a is going to be sine inverse of root 3a all over 2 will going to be sine inverse of root 3 divided by 2. It's going to give us 60 degrees. This is in degrees, 60 degrees. But we have to take note of our quadrants. We have the first quadrant. We have cast, C-A-S-T. Here it simply means all trigonometric ratios are positive. That means sine, tan, and cos in the first quadrant, which is 0 degrees to 90 degrees, are positive. 90 degrees to 180 degrees, sine, 180 to 270, 180 to 270 degrees, and 270 degrees again to 360 degrees. So we are from 0 to 90. Anytime you have an angle which is 0 to 90 degrees, either it involves sine or cos or tan, both of them must be positive. So since we're using sine here is positive. Since this angle is positive, that means false on the first. So where do we have again sine false? Because sine here again is positive, because this S simply means sine is positive. The remaining cos and tan are negative. For the third quadrant, tan is positive. The remaining sine and cos, they are negative here. If you come to the fourth quadrant, cos is positive, that this is positive, sine is positive, and tan is positive. So sine is positive here, the remaining two are negative. Tan is positive here, the remaining two are negative. Cos is positive here, the remaining two are negative. So we have to take note of this. So since this angle is positive, that means this angle of A will lie on the first and the second quadrant. That the first answer is going to be 0 to 90, that's going to be the first. And the second answer is going to be within 90 to 180. So those are the two answers we are going to have. So in this case, but if you recall the question, we are required to leave our answer in terms of radians, in terms of pi. So we are not going to find A here directly. So if we change this to pi, it's going to be 2A, it's going to be 60 times, what is the value of pi? When you change it from degree to radian, it's going to be pi all over 180. So this is going to give us 2A, it's going to be 0 into 0 is 1, 6 into 18 is 3 times, we're going to have pi all over 3. So therefore, divide both sides, the value of A is going to be pi all over 6. This is the value of A we are required to calculate. You see? We can as well go in to find the other value of A. We take this value from this point. We also say 2A is going to be 60 degrees. Since falls on the second quadrant from 90 to 180, we subtract 180 minus 60. This will give us 120 degrees. You see that? So this 120 degrees is going to be 2A equals to 120 times pi all over 180. You change it to radians. Pi all over 180, 0 cancels 0. So say 180 divided by, 120 divided by 180, going to give us 2 all over 3. So this is going to be 2 pi all over 3. So if we divide both sides, let's work it here. So this is going to be 2A equals to what? 2A going to be 2 pi all over 3. 2 pi all over 3. So 2 cancel 2. So A is going to be pi all over 3. But in this case, the question says 0 less than A and A is less than pi all over 4. I think that was that. So the answer should not be greater than this. So since this value is greater than this, so this is not part of the answer. So therefore, our required answer for this question only limited us to be A equals to, which is the first value, pi all over 6. This is the answer for this first part. I hope you enjoy it, so look at it carefully. So we move to the second part. The second part of the question reads, so we continue with the second question, and the second question is given us, it is given that y equals to x plus 1 multiplied by 2x minus 3 raised to power 3 divided by 2. So we are given a function to be y equals to the product of the two brackets. And what we are required to find exactly here, we are required to show that dy dx can be written in the form kx, the square root of 2x minus 3. You see, so this dy dx can be simplified in the form of this. And what's next? And we are required to state the value of k. We are required easily to state the value of k. So how can we easily state the value of k? So that's going to be our first part. And the second part is find in terms of p. We are required to find the results we are going to have should be in terms of p and an approximate value of y when x equals to 6 plus p. So in this case, the value of x is given 6 plus p. But in this case, because like most people try to misinterpret this second part, when they say we are x equals to 6 plus p, they might tend to take this 6 plus p and slot it here to find the value of y. We are required to find the approximate value of y. So you are not only going to take this value, slot it here, the result is going to be your value of y. You see, so you have to take certain stage. We are in the first substitute value of x as 6 in one case, and the other case substitute value of x as p in other case. From there, you add those two values. We are in p is going to be a very small value. Where p is small. So that's the second part. And the last part of the question reads, we are required to evaluate the integral. We are in 2,6 x square root of 2x minus 3 dx. So this is what carefully we are asked to do. So if we do that, we start with the first part, Roman 1. If we start with Roman 1, we are given y equals to the product of x plus 1, 2x minus 3, the power given is 3 all over 2. So this is the product rule. So the product rule involves with, so we have the formula of the product rule to be dy all over dx. We call it to be the product rule because we are multiplying two terms. You see, you can have two or more terms. Hence, you are multiplying two or more terms. The basic formula we are going to use is the product rule. Although you can even use the quotient rule. It depends how best you can able to take care of it carefully. You can use the quotient rule or the direct method, whatever method. So in this case, we are going to use the product rule because we are multiplying two terms. So if we use the product rule, we assume this first term is going to be u, and this second term is going to be v. So the basic formula we are going to use is going to be v du all over dx. Since we are using the product rule, we add and u dv all over dx. This is the basic formula. So since this is the formula we're going to use for the product rule, we need the value of v, we need the derivative of du dx, we need the value of u, we need the derivative of dv dx. This is it. It depends. You can say this the first bracket is u, this is v, or this is v, this is u. It depends. For in this case, let's say let u equals to the first bracket, which is x plus 1. So since u equals to x plus 1, now we have the value of u. It means 3 times 1, 2, 3. So how can we find u dx? We differentiate u with respect to x. So in finding the derivative of a function, it simply means you are reducing the degree of that function. The degree of x here is 1. If we differentiate this, we are going to reduce it from 1 to 0. So differentiate it simply means you reduce the degree of the function given. So integrate simply means you increase the degree of the function given. So if we differentiate this value, so if we differentiate u with respect to x plus 1, it's going to be du all over dx. If we differentiate x, it's going to be 1. And if we differentiate 1 is 0. So 1 plus 0 is just going to be 1. You see, the differential of a constant is always a constant. Because let's say if you have y equals to 5, this 5, we can also write it as 5x raised to the power 0. Because 5x raised to the power 0 is same as 5. So if we differentiate this y with respect to x, this will give us dy dx. So if we differentiate this value, we multiply 0 times this. Always when you differentiate, you multiply the power to the coefficient of the value. The result you have is subtract the degree by 1. So 0 times 5 is 0 times x to the power 0 minus 1. So 0 times any number is just 0. So if we differentiate 1, it's going to be equal to 0. If we differentiate x, it's going to be 1. When you differentiate a linear function, the answer is always going to be the coefficient of the linear. This implies if you differentiate 2, if you differentiate 2x, the answer is going to be 2. If you differentiate minus 5x, the answer is going to be minus 5. If you differentiate minus 100, the answer minus 100x, the answer is going to be minus 100. So the coefficient of any linear function is going to be the differential of any linear function. The answer is going to be the coefficient of that linear function. And again, the differential of a constant is always going to be 0. If you differentiate 1 is 0, if differentiate 2 is 0, if differentiate 3 is 0, any constants, when differentiated, the answer is going to be 0. When you differentiate a linear term, the answer is going to be the coefficient of the linear term. If it's having a negative sign, just take the coefficients and add together with the sign given, negative sign given. So now we have u and u dx. We have u and u. So it remains v and dv. Since we let u to be this, so v is going to be that. We also let v to be 2x minus 3 raised to power 3 all over 2. This is it. So if we differentiate v with respect to this, so it's going to be dv all over dx. So multiply the power, it's going to be 3 all over 2 into, we maintain the power inside, the term inside, and we subtract the power by 2 because we are differentiating. You always reduce the power by 1. We are not yet done. We already differentiate the power. Now we differentiate this term. If you differentiate 2x, like I was saying, when you differentiate a linear term, the answer is going to be the coefficient of a linear term. So if we differentiate 2x, the answer is going to be 2 minus, if we differentiate a constant, is 0. So 2 minus 0 is just going to be 2. So in this case, we can carefully see that these 2 will cancel these 2. So we have dv all over dx going to be 3 into 2x minus 3. 3 upon 2 minus 1, this is just half. It's going to be half. This is going to be this. Because if you write it 3 upon 2 minus 1, the LCM is 2. 2 into 2 is 1. 1 times 3 is 3. 1 into 2 is 2. 2 times 1 is 2. So 3 minus 2 is 1. So it's going to be half. This is it. So now we have everything we need. We have our v, which is this. We have our u dx, which is this. We have our u, which is this. And we have dv dvx, which is this. So we are just going to slot them into this product formula. So when we play with shorts, so at the end of the day, what we should have should be in this form. Should be in the form of kx, the square root of 2x minus 3. You see, this is simple and straightforward. So if we slot that, let's see how best what we are going to have. So we have dv all over dx equals to, you see. So I think here will be, okay. So now v is this, we rewrite it 2x minus 3 raised to power 3 all over 2 times v is this, and du dx is 1 times 1. We have our plus sign plus, and we have u is x plus 1 times dv dx is this, which we have as 3 into 2x minus 3 raised to power half. This is what we have. You see? That's what we have. So if we continue, this will be, so this time this we write this 2x minus 3 raised to power 3 upon 2 plus 3 here into x plus 1, and we multiply the bracket 2x minus 3 raised to power half. This is what we have, you see. But if you can look at it, this 3 upon 2 is the same as 1 plus half. 3 upon 2 is 1 plus half. So we need to separate these two brackets. So this is going to be 2x, this bracket can be simplified as 2x minus 3 raised to power half, and the other bracket is going to be 2x minus 3, you see, power 1, because this one bracket has been simplified into two brackets, plus, and we write this other bracket, 2x minus 3 raised to power half. So yeah, always when you are given it, when you are required to show something or to prove something, you have to work it according to the proof given. The proof here is going to be this form. So I think the square root of this is common. So here, you know, square root is a radical which has a degree of half. We also have a degree of half. Let's factor this. If this degree is factored, if we factor 2x minus 3 to the power half, if we factor this, what will remain is only 2x minus 3 plus. If we factor this, what will remain is only 3 into 3x plus 1, 3 into x plus 1, all brackets. You see? So I think this is what we are going to have. So this half, we can still rewrite it 2x minus 3 raised to power half into 2x minus 3 plus, this 3, we multiply it by these two terms. 3 times x is 3x plus 3 times 1 is 3. This is what we have. So in this case, this half is same as square root of 2x minus 3 into, here 2x plus 3x is going to give us 5x, minus 3 cancel plus 3, so everything is done. So therefore, that expression, which is dy dx, is equals to 5x, the square root of 2x minus 3. So this is what we are required to have. You see, so 5x is square root of 2x minus 3. So we are and state the value of k. So if you compare this kx square root of 2x minus 3 and 5x square root of 2x minus 3, this implies k equals to 5. This is the value of k we are required to find. You see, because these things, they are very simple and straightforward. We just have to take our time and we have them step by step. So I think we are done with the first part. And if we come to the second part asks us to find, in terms of p, an approximate value of y. We are required to find an approximate value of y, wherein the value of x is given as 6 plus p. And we are told that p is a very small value, you see. So I think we clear this part. If we clear this part to solve for, so we take second part, Roman 2. So Roman 2 says we are required to find approximate value. So to find approximate value, we are given x will be 6 plus p. We are not going to take x, slot it directly to this part. So we have to add the two. We have to find the value of x in terms of 6, and we find the approximate value of x in terms of p. So those two values, those two approximate values, we add them, so that will give us the approximate value of y. We need to find the approximate value of y in terms of x equals to 6. We'll find the approximate value of y in terms of x equals to p. Having those two values, so we can add those two values, that will give us the exact approximate value for y when x is given as 6 plus y. So let's go. It's very simple. We can start from the first part. We'll say the approximate value of y when x is 6. So we need to find the derivative. We say given dy all over dx to be 5x, the square root of 2x minus 3. We say when x equals to 6, so we are finding the approximate value of y. We are finding the approximate value of y when x is 6. So we slot it here. So dy all over dx is going to be 5 times 6. The square root of 2 times 6 minus 3. This is going to be 5 times 6 is 30, times 2 times 6 is 12, 12 minus 3 is 9, square root of 9 is 3, so this gives us 90. So we have result to be 90. So having that 90, we are done. But, the approximate change in y divided by approximate change in x is almost the same as dy all over dx. You see. So what we are looking for, we need to find the approximate value of y. So the approximate value of y, this multiplied by this is going to be dy all over dx times the approximate value of this change. So which implies dy dx, we already have it as 90 times the approximate change in x now is going to be p. So therefore, the small change in y, which is approximately going to be 90p. This is the first part. So we have the approximate change for y in terms of x equals to this. We also need to find the approximate value of y when this is this. Also, for y equals x plus 1 into 2x minus 3 raised to the power 3 all upon 2. We say we find the approximate value of y when x equals to 6. It's the same thing. So this is going to be 6 plus 1 into 2 into 6 minus 3 all raised to the power 3 all over 2. This is it. So if we simplify, 6 plus 1 is 7 into 2 times 6 is 12. 12 minus 3 is 9 raised to the power 3 upon 2. This can be written as 7 times, 9 is same as 3 square all raised to the power 3 all over 2. So this power will cancel this power. So this will be 7 times 3 raised to the power 3. This will be 3 raised to the power 3 times 7. 3 raised to the power 3 is 27 times 3, times 7. We have something like 189. So this is what we have. So you see, but now the question says find in terms of p an approximate value of y. So finding the approximate value of y for this particular problem. So say approximate value of y, approximate value of y going to be approximate value of y. So let's say, so the approximate value of y now in terms of x equals to 6 plus p, this is going to be approximate value of y for x equals to 6 plus the approximate value of y for x for change in y. We can just say change in y plus change in y. So therefore, the approximate value for x equals to 6 is this, which 189, and approximate value for change in y, which is 90p. So therefore, this approximate change are going to be 189 plus 90p. So this is the approximate change we are required to find, which is 189 plus p. We are in p is a very small value. So we are done with the second part. It remains the third part. The third part now says we are required to evaluate. So to evaluate this value, let's clear this. To evaluate this value, so we say Roman 3, the third part, we are required to evaluate the limit of 2, 6, x, the square root of 2x minus 6, and we are given the change in x, which is the x. So we are required to evaluate this. So to evaluate this is very simple as the first part and the second part of the question. So if we move now, here we let u to be the square root of this value, which is 2x minus 6. That u equals to this value. So if we make u, if we square both sides, this can as well be written as u square equals to 2x minus 6. This is it. You see? So we can easily find the value of x here. Okay, it was 3, sorry, 3. Instead of 6 is 3. This is 3. Because this is 3. The value of that is 3 here. So we can easily find the value of x. If we cross multiply, it's going to be u square plus 3. It's going to be 2x. If we divide both sides, therefore x is going to be half into u square plus 3. This is it. But since we have the value of x, we can easily find the derivative. Since we are required to integrate this, now we use the u substitution. Why we use the u substitution? Because if we say we differentiate the way it is, it's going to give us, we spend much time, so it will be somehow difficult. So the easiest way is we use the u substitution to break down this value. Using the u substitution, simply we are changing this variable x, everything to y, into u, because that's why we are using u substitution. We change this x to u, this bracket, all of this bracket should be in terms of u, and this derivative, the x, should be in terms of u. So changing that gives us the first step to say u equals to this square root, right? And we make the value of x. So therefore, this x automatically has become this. You see? So this square root, look at this square root has become u. So x is this square root is u. So what remains now is our dx. Because x is this square root is u, and the x is our target. So how can we find the x? So to find the x, it's simply we'll differentiate u. So differentiating u, since we have u equals to 2x, so we have u square equals to, we have u square to be 2x minus 3. We differentiate u with respect to x. This will give, we differentiate u multiply 2 times u, which is 2u, du all over dx. We differentiate 2x is 2, minus, if we differentiate 3 is 0, so no need. So this 2 comes to this 2. So we have u du equals to dx, we move there, dx. So this is it. So therefore, we have everything that we need. X is this, which we are going to slot. This bracket, this square root is u, which we are going to slot, and this dx is u du, which we are going to slot. So everything has changed to u, you see. And what remains here, the limit. You know, these limits, they came here with respect to x, so we cannot use them. So we need to change this limit totally to u. Because if we use the u substitution, so everything, the letter u, if we use u, so everything should be u. If you use k, everything should be k. It depends the letter you choose, like using. So since we use u as the substitution, so f, the limit again must be changed to u. So if we change the limit to u, changing limit, let's say changing the limit, we say u1, we have u to be the square root of 2x minus 3. So when x is 2, it's going to be 2 times 2 minus 3. This is going to be 2 times 2 is 4, 4 minus 3 is 1, and the square root of 1 is going to give us 1. We'll take again the second value, u2, the square root of 6. So 2 times 6 is 12. 12 minus 3 is 9. This is going to be 2 times 6 minus 3. This is going to be square root of 9, and square root of 9 is 3. So the lower limit here is 1 when x is 2, and the lower limit for u is 3 when x is 6. So everything has been converted to u. So we can easily plot them and find the integral of this. So if we do, let's see what we are going to have. So if we do this integral, which looks like 6x and the square root of 2x minus 3, the x can as well be written as, this 2 has been converted to 1, this 6 has been converted to 3. This x, look at it here, which is half into u square plus 3, half into u square plus 3 times x is half into u. So now this square root, this whole square root is u. So we have u times this dx. This dx, we have it to be u du, I think. So everything has been converted to u. So now if we integrate now, this half, we can write it outside. 1, 3, we have u square plus 3. Now u times u is going to be u square du. We have this. See? So if we continue half the integral of 1, 3, we expand the brackets. U square times u square is going to give u to the power 4 plus 3 times u square is going to be 3u square, all in terms of du. I think this is it. You see, so the question has been totally dismantled. Now, let's see what is going to be the next point. We integrate. If we integrate, as I was saying, when you integrate a function, the degree or the power of the function will increase by 1. And that total value is going to be divided by the function you have, or by the time you have. You see, so if we integrate this u, it's going to be u raised to the power 4 plus 1, which is 5, divided by 4 plus 1, which is 5. So therefore, this is going to be 5 all over 5 plus, if we integrate this 3u square, it's going to give you 3u to the power 2 plus 1 divided by 2 plus 1, you see. So 2 plus 1 is 3 and 2 plus 1 is 3. So therefore, if this is integrated, it's going to be 3u cubed divided by 3 raised to power, and the limit given is 1, 3. You see, this is what we have. So if we continue half, we substitute our limits. If the limits are substituted, we have half into, when u is 3, it's going to be 3 raised to the power 5 all over 5 plus 3 cancel 3. So it's going to be 3 raised to the power 3 minus into, when you always start with the top limit minus the lower limit. So substitute when u is 3 plus u is 3. Because 3 cancel 3 is 1, just with this. So minus when u is 1, say 1 raised to the power 5 all over 5 plus 3 cancel 3. When u is 1 is 1 raised to the power 3. This is it. So half into, because this will multiply by this. So now let's take this, both 3 raised to the power 5 will give us 3 raised to the power 5 will give us 243. This will be 243 all over 5 plus 3 raised to the power 3 is 27 minus 1 over 5 plus 1. So half multiplied by, let's take these two values. These two brackets, let's say bracket open, 243 divided by 5 plus 27, bracket close, minus bracket open, 1 divided by 5 plus 1. So a bracket close, So we have everything of this is 3, 7, 2 all over 5. So if we divide it, multiply it by half times half, we have 186 divided by 5. So if we divide it now, divided by that, it's going to give us 37.2. You see. So therefore, this integral, the integral of 2, 6x, the square root of 2x, not 3x, is 2x minus 3. The x is equals to 37.2. You see? So this is the end of this question. So we have solved 2 questions, and we take our time again to solve the last question. If we move into the last question again, so we try again the last question, and the last question is given as this, which is that. So the last question, the A part says, show that we are given tan square theta plus sin square theta divided by cos theta plus sec theta will give us tan theta sin theta. This is the first part of the last question, 3A. And 3B, the B part is given that x equals to 3 sin theta and y equals to 3 all over cos theta. We are required to find the numerical value of 9y squared minus x squared y squared. So we are required to find the numerical value of this. This is very simple and straightforward. So the first part, we are required to show that this equals to this. So let's try the first part. If we try this first part, so I think we need to clear this part. So if we can, so in this case, if we start here, we'll consider the left-hand side. Left-hand side. If the left-hand side is considered, which is tan square theta plus sin square theta divided by cos theta plus sin theta. So when we plug this left-hand side, at the end of the day, we are going to have something like tan theta sin theta. So if we have this, let's work it here. So if we move, we need to know the identity for tan square theta. Tan square theta is the same as sin square theta all over cos square theta plus, and we take sin square theta will just be the same as sin square theta divided by this division sign, we write it, and we have our cos theta plus sin theta. This is it. So here, this is same as 1. We find our LCD, the least common denominator, or we say we find our LCM, the least common multiple. So cos square theta times 2 is going to give us cos square theta. This cos square theta into this is 1. 1 times this is just going to be sin square theta plus 1 into cos square theta is cos square theta. Cos square theta times this is going to be cos square theta and sin square theta divided by, we write this, which is cos theta plus sin theta. This is what we have. You see? But if we look at this, because this is same as over 1. But if we look at this, sin square theta is common, sin square theta. If we factorize here sin square theta, if we remove it, it's going to be 1 plus cos square theta divided by cos square theta. You see, it's going to be this value divided by, and we have this value cos theta plus sin theta. So since we have cos theta plus sin theta, we write it divided by cos theta plus sin theta. So we have this value. So the next point again we are going to do, but in this case the final answer is going to be tan theta sin theta. You see, so it's going to be tan theta all over sin theta. So, but we can find the value of cos square theta, because cos square theta is equivalent to sin square theta. Cos square theta is equivalent to 1 minus cos square theta. But sin square theta plus cos square theta are going to give us tan square theta. So the next version here is going to be, so the next version here is going to be this. But there is something, yeah, okay, well, okay, Here, the question gives tan square theta plus, I think this should be sec square theta. Sec square theta, so it's not, I think, we need to rewrite this, not sine, but it should be sec square theta. Sec theta, because here is sec theta, yeah, sec theta. So cos theta plus sec theta. So that means we need to find the identity for this value. So cos theta, we maintain it plus sec theta. The identity for sec theta is same as 1 all over sec is cos, 1 over cos theta. Yeah. So here again, we need to find the LCM. The LCM is going to be cos theta because 1 and cos theta, they are the denominators. 1 into cos theta, cos theta, cos theta times cos theta. We're going to give us cos square theta plus cos theta into cos theta is 1. 1 times 1 is 1. So yeah, I think we have it now. So instead of sec, we wrote sine. So in this case, division, we can reciprocate this value. This denominator will move up and this numerator will come down. It's going to be cos theta divided by cos square theta plus 1. So if we look at them, this 1 plus cos square theta will easily cancel 1 plus cos square theta. So what will remain is sine square theta divided by cos square theta times cos theta. You see, and this cos theta again, we can, but we cannot cancel this because we are required to show that tan theta sin theta divided by this. But this sin theta, we can write it as sin theta sin theta, right? This cos theta again can be written as cos theta times cos theta. You see? So therefore, 1 cos theta will cancel 1 cos theta here. So it's going to remain sin theta divided by cos theta times sin theta. So therefore, this implied sin theta divided by cos theta is easily tan theta times this sin theta. So this gives us the derivation to be tan theta sin theta. So this is the derivation easily we are required to show. We are required to show when we plot this tan square theta, sin square theta divided by this, we're going to give us tan theta sin theta as we have. So the A part is done. So we are coming to the end of the video. So the B part, we are given that x equals to 3 sin theta and y equals to 3 all over cos theta. Find the numerical value of 9. So we are required to find the numerical value of this guy. What is the numerical value? What is the value of this guy? What's going to be the value of 9y squared minus x squared y squared when we play with these two guys, x and y, which is also simple and straightforward. So if that is simple and straightforward, let's clear this. So since we are only given x, so x equals to 3 sin theta. As we have here, we can make sin theta the subject. So if we make sin theta the subject, it means sin theta is going to be x all over 3. Let's say equation 1. We are also given y equals to 3 all over cos theta. If we make cos theta the subject, we interchange. Cos take the place of y move to the place of cos. So this will be 3 all over y. This gives us 2. You see? But we have to take note of that. There is an identity which is very useful. Sin square theta plus cos square theta equals to 1. So since in terms of this, so what is the value of sin theta? Sin theta is this. Since here is squared, it's going to be x all over 3 all square plus, what is cos? It's 3 upon y. Since here is square, it's going to be square equals to 1. So this is how we easily find the numerical value of this. So if we simplify, if we square the 2 terms inside, if we square x is x squared, if we square 3 is 9, if we square 3 is 9, and if we square y is y squared equals to 1. Very simple. We'll find the LCD or the LCM. The LCM between these 2 terms is going to be 9y squared. 9 into 9 is y squared times x squared, going to be x squared, y squared. Y squared into 9y squared will cancel y squared. It means 9. 9 times 9 is going to be 81 equals to 1. We cross multiply. So we have x squared, y squared plus 81 equals to 9y squared. This is it. So, but the question says, what is the numerical value of 9y squared minus? So that means 9y squared, we transpose this. If this is transposed, we have 9y y square minus, we transpose it, which is x square y square, will be 81. So therefore, the numerical value of 9y square minus x square y square equals to 81. Thank you. Please make sure you subscribe, you like the videos, and as well as you leave a comment. Thank you. Stay blessed.